Alright guys, today I'm going to show a video on how you can download and install OpenCV, integrate it with CMake and the Afterburner engine such that you can run a module that needs to use OpenCV for purposes such as stereo block matching or something like that. Alright, we're going to assume that you have not installed OpenCV at all, and we just go to the OpenCV website, and I will download the latest release. This is OpenCV 4.2. I will download this for Windows. This will take us to a SourceForge mirror. I have already downloaded that executable. That executable is right here. When you double click it, it's simply a self-extracting archive. I will extract the archive to OpenCV 4.2.0. Alright, imagine we just watched that extract, and we can look inside of this folder right here. Inside of this folder, we see these are the values for OpenCV. Now, all we've done up until this point is download an archive off the internet and extracted it on our hard drive. This is not enough information for the C++ compiler, MSVC specifically, to know that we have installed OpenCV. It doesn't know where to look, where the include files are, where the linked libraries ought to go, and where the dynamic DLLs are located in our path. So we haven't set any of those, but let's just assume everything is set, and we'll try to build a module and follow the errors that it gives us to troubleshoot what we need to do. All right, so I am going to go to the stereo cam module. This stereo cam module requires OpenCV, and I'm going to start by running CMake. When I run CMake, we can see that we have OpenCV checked. We want to use that. And when we click Configure, we get an error. That error is saying that it cannot find OpenCV. If we look closer, the error itself says that it could not find a package configuration file for OpenCV, and it has this name right here. So CMake is literally looking for this particular file, and it is saying that it is looking for this particular file by searching your environment path for a variable called OpenCV dir, and this environment path OpenCV dir should point to where this file is located. All right. Since we just downloaded OpenCV, we can search that archive for that particular file. All right. So if we say find pipe to egrep case insensitive search and then search for OpenCV config.cmake, we can see that the file appears in several places. The first place it appears is OpenCV config inside of the build folder, which is right here. The second place that it appears is in build x64 vc15 lib OpenCV config. All right, and vc14 as well. What this is saying is that this is the specific configuration for the 64-bit version of Microsoft Visual Studio 15 compiler, which is the latest version of the Microsoft Visual Studio compiler. So if you downloaded Microsoft Visual Studio Community Edition 2019, you would be using, I believe, the VC15 MSVC compiler. So the difference between the one inside of build and the one inside of VC15, there could be several differences. If we want to look at those differences, the first thing I can do is I can right-click on that first file we found, go to tortoise get, say diff later. Then I can also go into the build x64 folder, into VC15, into lib, and find the OpenCV config.cmake. Now I can right-click, say tortoise get diff, and if I look, there's actually quite a few differences between here. Just based on experience, I would choose to go with the more specific configuration for my machine, which means that OpenCV dir right here, this OpenCV dir that CMake is asking us to create and populate, I will point to the one on the right side, which is the VC15 specific version, because this is already the configuration we want for our compilation. All right, so what I need to do is go into the environment variables, and I will create a new variable named OpenCV dir, and the directory that I want to put into there is indeed this directory right here. So paste and paste. We click OK. We click OK again. And now, if we, for example, open up a command window and type environment, we will see that there will be an OpenCV directory right here, and it points right to where we said. Now, when we run CMake again, it will find this OpenCV dir and try to populate that. So if I just hit configure again, it did not find it because it is still using its old cache. So what I'm going to do here is I'm going to exit out of CMake. I'm going to go to our C164 folder, and I'm going to delete the old CMake stuff. And I will rerun CMake from scratch. This time, hopefully when we click configure, we now see OpenCV, and in fact we can see that it found the exact location we're looking for. All right, so we can click generate, and when we do that, we now have stereocam.sln. So let's open up this module and try to run it. Right? There is one more error that we are likely to encounter, and that is the DLLs are not yet in our system path or in our environment path. So the first thing I want to do if I want to run this is I need to right click on StereoCam and say set U as the default project. What I can now do is try to run the project, and when we run the project, everything should compile and link properly, but upon launching, the executable will try to load a dynamic DLL specific to OpenCV, and in this case it is literally called OpenCV World 420.dll, and it says that the code execution cannot proceed because this DLL was not found. Reinstalling the program may fix the problem. Well, reinstalling will not fix it, but what we can do is just find that. So again, I want to find, and I will search for OpenCV underscore World 420.dll. And if we look, we again have two different versions, one for VC15, one for VC14. So if we go to this in a little browser here, we can see that in VC15 we literally have the bin right here. We have the file OpenCV World 420.dll. Okay, so what it means is our environment variable, our path variable for our environment needs to include this folder right here. Now, if we look closely at what do all these DLLs mean, this DLL is the primary release mode DLL. All right, so when you run in min-size rel or release mode, this DLL will be dynamically loaded at runtime. All right, this has the release binaries that get loaded at runtime. The one that ends with D is for debug mode. All right, on Windows, this .pdb file also get loaded because this has some of the debug symbols in it that get loaded with the debug version of the DLL. This will let you step into OpenCV function calls right there. Suffice to say, you want this whole path in your environment. So we will go back to our environment. We will go back and look at our path variable, because whenever you type an executable, like if I type, dir or ls, for example, ls was in my path. All right, on Linux that's like /bin or /sbin or something like that. On Windows, it could be in your Windows System 32 folder. All right, suffice to say, I'm going to make an edit to our path variable. I'm going to insert that path right there. All right. Now, this is at the bottom, the very bottom, which means that the operating system will search everything above it first. So I'm just going to grab it and move it up. That way, if there are any other OpenCV DLLs that just happen to be somewhere on my hard drive, it will find this one first. All right, and so I'm going to put it right after the engine afterburners lib64 folder. So I'll put it right here. I will click OK. I will click OK. And at this point, we should be able to run. Now, there's one last gotcha. That last gotcha is I'm going to try to run this thing again. And I get the exact same problem. What gives? Well, the problem was I changed my path, but I did not exit out of and restart Visual Studio. Remember, when you launch a process, that's when it grabs a copy of your operating system's path variables. So now that I've changed the path, I'm going to open up Visual Studio again, and now I will try to run it. Okay? When I try to run it this time, we will see it compiled, linked, and it is now properly running. And so right here, we can see we have this up and running. And to verify that we are indeed using OpenCV, let's take a look and see. So we can see right here, let me minimize our GUI, that we are generating a point cloud of this A10 aircraft right here. And that A10 is being generated from stereo block matching using a left camera and a right camera. If we look closely, the camera is actually right here, this little guy right here, looking at the airplane from this perspective, and the points are being reprojected as though they were located at the origin in this direction. If we look at the left camera, the tail of the A10 is closer to the top of the frame than the tail in the right frame. All right, so the cameras have a little bit of a rotational offset between the two. Anyway, if we look, we can make our little GUI here and do some sort of weird things. If we actually take the GUI, which is sort of an orthographic overlay, and we put it in front of the camera, which you can see through the left and right frames we are adjusting, you can see that it sort of screws up our airplane, and our real-time stereo block matching gets messed up by the GUI. If we want to make the GUI move a little bit, let's say we go and we add a little plot that's going on in here. Now it's a little funny because we're feeding orthographic data into a stereo camera, and as that happens, we can look at the point cloud over here, and it does all kinds of like weird dirt that we're getting over here. And again, if I minimize this, boom, back to our clean point cloud. All right, so suffice it to say, now we are doing real-time stereo block matching. We installed OpenCV. We set up our environment path for the OpenCV dir such that CMake can properly find it, and then set our VC project to link and include the proper OpenCV libraries and header files. And then we also added the OpenCV binaries into our environment's path variable such that when we launch our executable, be it from Visual Studio or command line, it will load that DLL because it is found in the path, and then we can use it in real time. All right, so that will conclude this video. Thanks.